Good morning, students. We're going to go ahead and work a few problems related to today's absolute value assignment and hopefully hit a few highlights for some of you who wanted to review a few things. We're going to start with this problem here. I'm on page 7 of your Big Ideas book. It's wanting you to basically use a table of values to graph these functions and then talk about domain and range. So, table of values I have here, and this -4 means I'm just going to substitute that -4 in where the x was. So instead of having an x there, I'm just going to replace that x with a -4. So the absolute value of -4 is how far it is away from 0. So that's 4 times 1/2 would give me a value of 2. So that's your first point there. Then when I come to the next point, I'm going to go ahead and plug in a -2. So I'm going to put a -2 in there where the x is, literally replace the x with a -2. Absolute value of -2 is 2 times 1/2 is 1. And I can continue that all the way across my paper. Plugging in a 0 means that I have the absolute value of 0. Well, 0 is 0 away from 0. 1/2 of 0 is 0. And then I would continue by plugging in a +2. A +2 is just 2 away from 0, so that's a 1. And then if I were to plug in my 4, the absolute value of 4 is 4. 1/2 of 4 is 2. So that's what I'm going to end up with. So I end up with a series of points here. I have the point -4. I go over to -4 up to 2. So there's 1 point, -2, 1, 0, 0, 2, 1, 4, 2. And then once I have these points, I'm going to connect the graph. Remember, we discussed yesterday an absolute value makes a V-shaped graph. So one way to remember that is absolute value makes a V-shape. See, I will make myself look like a fool to help teach you. So an absolute value graph makes a V-shape. So a nice straight line on both sides. That's as straight as I can draw with this screen. And then a point there. And this point in the middle is actually my minimum value, and I think it's helpful to label that minimum. In this case, my minimum is 0, 0. If the graph was pointed upside down, it would still be a vertex, but the vertex would be a maximum. Now, one reason I think it's helpful to do the minimum is the other direction on this is to talk about domain and range. So when I'm looking at domain and range, my domain for this first graph is going to be my x values. Domain is always x. So as I go over to the side, I see that the x values keep going and going and going and going as far as they want. They can get as big as they want. And on the other side, they can get as small as they want. I can go as far as I can to the left in the negative direction, as far as I can to the right in a positive direction. So my domain should be all real numbers. And the shortcut to write all real numbers, once again, is just the fancy R with the double line on the leg. So that's what you can do for your domain. For your range, and you can write out the word range or just abbreviate it with R, the range is your Y values. Well, once again, my Y values can get as big as they want. They can go up and up and up and up and up and up. Very positive. Whether I'm going to the left or to the right, they're going up. But there's a limit to how small they can get. They get stuck there near 0. And they do not get any lower than 0. So for my range, it has a minimum value of 0 and a maximum value of infinity. Now, when we use interval notation again, I'm going to start with my small value. In this case, my minimum is 0. And then I'm going to put my large value, my maximum, which is infinity. I'm going to put a parenthesis for infinity because although you keep going up forever, you never actually get to infinity. And I'm going to put a bracket for the 0. So that is going to be help